Hello there, good afternoon everyone. Today we are live from Just Join IT HQ and my name is Marcin Kwiatkowski and I'm technical lead in Just Join IT. Today we're gonna talk about definition of serverless and actually how not to overhype and create a reliable system. But before we start, I am thrilled to introduce my special guests today. Michał Nagórski and Michał Wikliński. Thank you guys for being with us today. And before I give you the floor, I would like to inform you, all of you actually, that in the very end of our live today, I think it would be about 15 up to 20 minutes, we're going to have a Q&A session. So I strongly recommend and ask you to ask any question on our social media. Today's presentation, of course, would be in English, so please be focused. Guys, I'm giving you the floor. Please proceed.
Thank you. Thank you. Welcome everyone to this the presentation. As mentioned, we'd like to chat about the serverless, maybe not the full definition of it, but how we are defining it in OLX in the real estate department. And we would like to show you how we are working with it and what does it mean for us to not overhype with the technology. But before we go to the topic, let's make a short intro about the OLX Group, because as you probably know, OLX Group is not only one portal in Poland, but we are the OLX Group operates a network of online trading platforms in over 40 countries under more than 20 brands. In case of Poland, we are operating in four main formats, which is one is our main platform is horizontal OLX.pl, probably well known for all of you. In case of the cars industry, we are operating Otomoto, 321 Sprzedane, Otomoto Click, and CarSmile. In case of real estate, we have two brands. One is Autodom, second one is Obido. And in case of services platforms, so if you would like to ask someone to build for you IKEA stuff, you can go to the Fixly and ask for a support there. So basically, if you are joining the OLX Group, you'll be joining more than 11,000 employees all over the world. And in Poland, we have offices in Poznań, our headquarters, Warsaw, and Kraków. And for most important thing, I would say is that we are offering fully remote work for engineering departments. Okay, so let's move.
Yeah, let me introduce myself and Michał, of course. Who are we? We are still programmers. We've been in the industry for over 15 years. I worked mainly in tourism industry. Michał worked with telecoms, finances, and also many others. And what I would like to emphasize today for today that everything that we say is based on our previous experiences. So it's not something like this artificial or drawn out of nowhere. It is some of our experiences. So yeah, let's talk about this serverless thingy, what it is, and how can we approach this serverless stuff. At the very beginning, it may seem that there are no servers, of course, but it does rather mean that we as programmers don't need to bother of configuring them physically. So we don't need to worry about updating operating systems, configuring physical networks, fiddling with hardware, things like broken disks or something related to hardware. It can be really painful. I could say from my experience that hardware failures, like hard disk failures, are the most common ones when you get something really big in the production. So this is, I would say, constant. So in theory, serverless, it's like it could look like there are no servers, but all of that is still there. So how the situation looks on the market. We got like 3 key providers or vendors of serverless services. We got also plenty of others, but I will not focus on them. The main things that you should know that there are web services from Amazon, very similar stuff from Google. There's this GCP, Google Cloud Platform. We got Azure from Microsoft. And as I mentioned, plenty of others. The Oracle has something, IBM has something, like pretty much everybody has something on their plate. And we also have something which is called Kubernetes. And many of you could ask a question: is it still a serverless because it's in the cloud? You know, so we could argue about that for hours. I don't want to go into details right now, but it runs in the cloud, of course. But I would say we should think about Kubernetes as a framework to run distributed systems. I would say that. So it's it's a bit like serverless. It allows us creating complex architecture with a low effort of sysadmin, but those. At the very end, both approaches for serverless, like Kubernetes or those previous services that I've mentioned, these are something which transforms this classic deployment approach, which is very people-intensive, to something which is more automated, more quick, more smart, I would say. Yeah, let's jump to serverless, because this is the main topic of our presentation for today. So serverless approach solves us a lot of problems, although it still kick you. It still can kick you. So it's not like it's the remedy of all of the world problems. We get plenty of other problems to approach. So from the first side, programmer and people involved in the process do not need to worry about infrastructure so much, but it doesn't mean that there is no infrastructure, right? As I've mentioned. The second benefit, which is quite good, I would say, especially in some cases, that we got auto scaling. So our services can be scaled almost automatically, and at the very end, we pay for what we use. So this is either your enemy and your ally. It really depends on what's the product and which approach will you choose. So be careful with that last point. We will go back into that at the later stage of our presentation. Michał will elaborate more on that as well. So speaking of this whole serverless thing, I would say when we try to design a product and we try to create an architecture of our platform, we should ask at least several different questions. At the beginning, when there are situations where scenarios are very simple. So there is like a no-brainer, right? So you ask yourself, should I go serverless or not? When your service is simple, when you have something like CRUD application, you know, this create, remove updates and stuff like that, it is a good idea to some point. When you're prototyping, when you're creating a proof of concept application, even if you have a bunch of scheduled jobs, is a very good idea to go with serverless, because it solves us a lot of problems and do not add anything special that we should care about. There are also situations or things that serverless suits well, but we need to consider at least some drawbacks. For example, when we got this microservices architecture is quite popular right now still. And as long as microservices are stateless, you're good to go, I would say. Because anytime that you have something that you need to store onto your hard drive, save something on your disk, which is not a database, like we have another server with the database. As long as you do that, is okay, because you need to remember one thing. For example, Google platform or Amazon, AWS, they can turn off your pod, for example, and before even letting you know that something happens. So you should be prepared for that, that your microservices should be stateless, and it will save you a lot of trouble. And yeah. Also, serverless approach suits well when we get like irregular traffic with a lot of spikes. For example, when we have an online shop which is expecting a high traffic on Black Friday, for example. When we have that, it's quite easy to add another machines, to add servers to our infrastructure. We don't need to buy them. We don't need to configure them. We don't need to have people to transport them to the server room, for example, and fiddle with the cables. It's a lot of work. So this approach, either serverless or the cloud computing in general, suits well in this scenarios. There is also a third thing, and I would say this is the most important one. You should ensure that you have at least skilled people to manage all of this configuration. You should have some DevOps team or site reliability engineers, because if you don't have these people, your programmers will not be able to cover all of that stuff. So at some point, you don't need people to manage your hardware, but you still need some people to manage your configuration. And the more complicated or more complex your product is, you will need more people. So starting with something really simple can be very costly at the very end. Michał will elaborate on that more because he will have some story for you, but I'm just mentioning it because it is still really, really important. So make sure that you do not overcomplicate your architecture, but I would say this is something like a general advice for the architecture. So keep it simple. As long as you have simple architecture, you're good. You're good. And of course, last but not least, you need to understand serverless platform capabilities, because each vendor has its own drawbacks. Each vendor has some quirks that you need to know about. And yeah, Michał will also mention that in his part of presentation. This is something that can really kick you, especially when you get your product running in the production. So just to summarize this serverless introduction, I like telling a story, so I'll tell you a story as well. Here, in 2016, we had Australian Bureau of Statistics, like our Polish goose. They had a census, which is like voting when people come to the online site and vote for something, and yeah, just store something online, which is it does seem really, really simple. So I would say the basics of all of that was that 16 million Australians were expected to complete the census entirely online. It was the system created for this only purpose. It cost a lot, like $10 million, several hundred thousand was only for testing. When we realized that at the very end, it appeared that those testing were probably done manually, but nobody admitted that at the end. This is really funny. But as you may expect, of course, this is a system which needs to be designed with some high capability regarding being online, right? So it needs to sustain even when the traffic is high. So this official site, I can say, just after that, it crashed almost immediately. Just right after launching, it crashed, and nobody wanted to use it anymore. So yeah, this is the long story short, no details, right? I'm just telling you this because the story is funny at the very end, because two students after that, they were like on a hackathon or something like that. They wanted to learn something new. So they started to, they wanted to learn AWS because they had no idea how does it work or how did it work at that time. So they created a simple, very similar system just for voting to handle the census situation in Australia. So remember, two people, they created a very similar system. They scraped the official HTML from the online side because the original one, they didn't want to waste time for that. And they did it over the weekend. So it was super cheap, super easy, super basic stuff. One S3 bucket, several pages, one API gateway, which triggered this Lambda function on. So everything was like serverless. And DynamoDB, which is the main database from Amazon, was storing the data. So everything cost like several $100, and they were able to test it with a special tool created for these purposes, also worked in AWS. So they were artificially able to generate traffic like 100,000 concurrent requests. So it's a lot. So two students were able to do that over the weekend for $500, and the system just worked. So this is the funniest thing, that the system, when the technology is chosen right, the system can work and can serve a lot of people. So I'm just telling this for you because not to laugh at somebody, but to show you that this kind of work is possible. Yeah, but speaking of stories, I think Michał has something for you as well. The story from OLX this time. So Michał, go on.
Yep, thank you. So I would like to present you serverless story, our story of using serverless and learning serverless in the real estate customer unit. But before we started, I would like to rename it a little bit. So not serverless story, but the drama in 6 acts. Why drama? You will see at the end. Maybe it's not a drama. We will see. So let's start. Our story starts with the simple idea with making something simple just to provide one JSON. So let's start with the idea. So the overall project was aimed to give ability to our subsystems to retrieve configuration stored as a JSON object, a pretty big JSON object, and return it without any kind of transformations, editing, just return the content from database. So after short time, we decide how we can approach it. So we decide to use serverless. Everyone has a hype for serverless, and before we move to the code, a couple of things that needs to be assured. We use AWS as a platform. We use Terraform as an infrastructure, as a code for our all work. Whenever we'll go speaking about the lambdas, we use the Golang, and we use GitLab runners to perform all kind of CI/CD work related with the serverless. So after the idea, we go to the step number 2, which is simple CRUD. In Amazon DynamoDB, with the direct connection between them, this is possible with the Amazon API gateway, a request templating service. So we don't need any kind of lambdas or anything inside here. We just make directly from gateway call to the DynamoDB. For one of the endpoints, we figure out that from time to time, the content is cut. Why? Because we start using the loops for each loop inside the transformation. But what is the transformation? Maybe I will show you. This is our example project used for this presentation today. We have the API defined as a YAM. This is open API definition, which we feed to the API gateway to build all the APIs. We have DynamoDB, and very important thing, IAM. In all cases, whenever you work with the cloud providers like AWS, you need to give ability to perform some actions. It can be read, it can be write, depending on your needs, but this is configured by the IAM roles. So we start our implementation. Inside the API gateway definition, we create something like that. So we define the API. We said, okay, this API will make direct integration to the DynamoDB with the query operation. We provide the credentials, so the IAM role, and make our request template. So whenever someone is requesting something, we are going with this template to the DynamoDB. One of the key elements of our database was that one of the columns inside it was defining the customer type. So depending on the customer type, we always need to return only one entry, the latest one, the newest one. So we can pass it as a customer type, as an input parameter to our query. Everything goes smooth. Whenever we make a Terraform apply, we can see something like that inside the AWS console. Everything works, we can test it, click it. Beautiful, it works. But at this, so we finished the first sprint. Everyone is happy that we have established the serverless principles for our work. But as it is in the agile manner, we get the new requirements. And in here, we are going to the act number 3, which is more and more CRUDs. What does it mean? So we have a next idea. Instead of making some manual changes, we would like to store the data inside our DynamoDB for one of the tables, but we need to validate input. Okay, so this is one of the key assumptions, that we need to validate the input and return proper error messages, detailed error messages about which field needs to be updated or changed to fulfill the validation. So the solution was very simple. No more direct connections from the API gateways to the DynamoDB or other DBs. We will use AWS Lambdas as a bridge for such operations. So inside the Lambda, we create the logic to validate the input. If everything is okay, we store data into the DynamoDB. If not, we are returning the error to the customer through the API. So our initial design has been changed for safe operations. We established a set of lambdas, which give us ability to perform actions like validation. Everyone was happy. We go to the production. Everything goes smooth. Of course, the next step approaches us, so act number 4, need to call third-party system. Our service was growing because we have the slight changes in the requirements. Everyone was happy with the idea how fast we were delivering the software. So we decided to extend the system for a couple of new things. So let's go there. So basically, our system is no longer a standalone element. Right now, we need to communicate with the third-party applications and services. So how we can approach it? Very simple. We will use more AWS Lambdas. For each endpoint, whenever we need to go to the third-party system or integrate it, we can use AWS Lambdas. So let's go inside there. So we redesigned the system. We create the next set of the Lambdas, which were communicating with the subsystems. Everything during the tests goes smooth, so something similar as Michał presented in the case of Australian CESUS. On staging environment, everything goes really fast. Everyone was so happy that we decided to go to the production with our solution. Unfortunately, we hit the wall. And the wall was one of the third-party services. Response time on the production was unpredictable. We were, depending on the situation of the element of the day, we get the very long or very short response times. This caused at high loads, our API was failing. And this is the time to, before we go to the solution for this, to mention first element of the lessons learned from our perspective. We need to implement proper monitoring for our ecosystem. In this case, we weren't sure what is causing our problems. We have some basic logs, we have some X-ray enabled, but we wasn't able to determine what is the cause of our troubles. After enabling the detailed X-ray, detailed analysis of logs, we've spotted one of the systems is failing quite often during the high peaks. So we double check what kind of data it's returned, and it seems that, okay, we can cache it. And the easiest way, let's cache it. But of course, we are programmers, we'd like to complicate our stuff. So instead of simple cache on the Lambda, we said, okay, let's make a play with this AWS. So we decide to use CloudWatch events. Each time-based event is emitted. This time-based event is kicking our Lambda, which goes to the third-party service. Get the data. If everything is okay with the data, store it in DynamoDB. And our Lambda, which previously was directly hitting service number 3, right now starts reading the data from Amazon DynamoDB. And in this time, we have around 40 different Lambdas, couple of Dynamo tables, and service was working smoothly after these changes. Unfortunately, the hype for serverless was here with us. Other teams inside our team says, okay, we would like to use the serverless as well. Let's clone it. Let's clone these principles which we've created. It's so easy and nice to develop in here. And this was the first time when we met AWS soft limits. Each AWS account has its own limit, its own quotas. It can be quotas for amount of S3 buckets. It can be amount of AWS Lambdas, even amount invocation in single account of the Lambdas. So this is the second lessons learned. Always double check your quotas. And in our case, the solution is very simple. We send a request to update the limits to make it a little bit higher. The problem was solved. But of course, there's always some buts. We move forward. And we are stepping in to the Act 5. Need to perform complex calculations. What does it mean from me, complex calculations? In our case, it forced us to go to, we faced this topic. The task was very simple. Recalculate the data returned by other subsystems and limit output to single response. So we would like to go to several systems, get the data from there, make based on it some recalculations if required, combine to one big response, and return to the customer. As previously mentioned, we have such Lambda which was able to communicate with a couple of systems, but we were smart enough to say, okay, there can be a problem with during the peaks. Unfortunately, there's a next requirement coming in. This data needs to be captured once a day, kind of a report, because it's not changing it's changing so often during the day that the customers should see it as a report from the day before. So we said, okay, let's use the CloudWatch events, which we have already there. And we were using it fully. It was working very, very nice. Unfortunately, our product says, okay, but we are operating in several countries with the same stack. And for this particular report, source of the data depends on the country. One of the third-party software was the invoicing system, and depending on the country, we have different systems. So this is the next task, which said, okay, we cannot make it so easy that we'll code it somewhere in the Lambda that go to the system, get the data, and make the calculations. But of course, we're engineers, we always find solutions. So we decided to use step functions to orchestrate our processing. Because we are using Terraform, we were able to make very smooth configuration of our infrastructure depending on the country, and everything goes smooth. But let's see the design. So from our simple service, we create additional step. We get the new AWS Lambda to get the data from DynamoDB, because it was we would like to double check for which user additional layer of checks in here, so not direct call from the API gateway, but we feed this data to this table based on the time-based events. So once a day, there's a trigger for our step function. The step function, first of all, goes to our internal database, but through the Lambda. So our Lambda was capturing from the couple of tables data and sending it back to the step function as a context of the invocation. So other Lambdas, if needed, can use this. The next part was service number 4, which was changing depending on the country. So this is kind of an invoicing system. So we make an for the context of the step function, we try to inline the data in there. So depending on the service, this part of the system was changed based on the location of the deployment. And service number 5, which was same for all the countries. And at the end, we gathered the data and send it back as a JSON report and then serve it to the customers. And right now we are approaching act number 6. Was it failure? As mentioned previously, during the journey, we faced several issues, from very simple like soft limits to a little bit more harder like subsystems not responding well for the high loads. So in overall, was it failure or not? But before we answer the question, let's double check our journey from the Act 2, so the and Act 1, so the simple idea to this at the end of the system. As you can see, we start with 2 AWS services. After around 4 sprints, we finished with the bunch of the Lambdas, bunch of the Dynamo tables, several step functions, several time-based events, and together all of this, as you could probably understand, it was fine. But of course, there's a but. I love this word. But we make a step back, try to understand our mistakes, and make it happen, and work with the serverless, with the really successful right now. And question to you, are you interested in how the story ends? So how we are working with the serverless? Guys, if yes, there's a very simple answer to this. You can join us at OLX to see how this story ends and how we are using in several countries the serverless itself. Of course, the journey of ours was very bumpy, but I would like to sum up and give you a couple of takeaways from this presentation. So first of all, double check the requirements. If you are working in agile world, after several steps, always double check the requirements still fits the serverless, the pure serverless, which we present during this journey. As there can be there is a possibility that, for instance, Kubernetes and microservice deployed to the Kubernetes can be better for you. So this is very important to always try to understand the requirements and double check where we need to move. Still keep the serverless or go to the Kubernetes. The next thing which we didn't, the next bump which we faced was limitations of the cloud provider. As mentioned, AWS has soft limits and hard limits. In case of the soft limits, we can make a query to the AWS support and ask them, okay, please amend the quotas so we'll be able to move forward. But you can face the limits, the hard limits, which are not amendable, and you'll not be able to do it anything else. In this point, very important is, as Michał said at the beginning, you need to fully understand the good practices of creating serverless software for each cloud provider. In case of AWS, very nice guideline is well-architected review, which help you to understand the set of the accounts, how the sub-accounts should work. There's an asterisk in here. If you are using multi-account setup, always double check your services which are using, because you can face additional costs related to transition between the accounts. Next thing, don't forget about the observability and monitoring. This is the crucial in case of the serverless. As you can see, in a couple of weeks, we two AWS services, we grow to the several services. Each time when you add new things to the serverless, you multiply the services, and the tracking of the request inside is very important. So whenever you try to figure out what is happening without proper monitoring, you'll not be able to do this.
Yeah, this is something where the real cost is at the end, right? Comparing these two simple services, the very simple at the beginning, the very complicated at the end, and this is a place where your dollars are.
Yes, exactly. Monitoring is one of the most cost generation parts of the whole serverless. In case of the double check the results, what I mean here, whenever you make some changes to the infrastructure, this is why you need the DevOps or SREs in your team. Double check what are the outcomes of your change. You're probably modifying the production services, and the step back, so kind of a rollback, is a little bit harder than in case of the Kubernetes, where you have Docker images which you can roll back easily. So always double check the outcomes of your deployments. And the last but not least, periodically check infrastructure cost.
Oh yes.
During our journey at the beginning of it, we didn't check periodically the cost of our infrastructure, and right now we are able to spot the gaps in case of the elements that cost us a lot. We have a couple of APIs that require refactoring, because we find out that we can make it better. We can use the events instead of direct calls to ensure that the data is set for our third parties, for our users, so they can get the data not so often by the API calls, which are costly, but through the single event, and they can just store it inside their own service to get the results. Okay, so guys, thank you for the presentation, and waiting for questions.
Yep.
Yes, thank you guys for sharing the presentation with us. It was an extremely high dose of specialist knowledge, so thank you. To all watching us, I would like to remind that you can ask any questions on our social media. We are moving, of course, towards a Q&A session, and please do not hesitate to check current job positions at OLX. So the proper link is in the comments, actually. I've just got the info that the link is there, so you can check it out. All right, guys, are you ready for Q&A session? There are some questions to you, so...
Sure.
All right, so
Go ahead.
let's go on. Okay, the first question is from Maciej. He's asking, I will simply read that. Have you considered using AWS CDK as a infrastructure as a service, would better, instead of Terraform? Actually, it's not connected with serverless, I think, but have you considered that?
So maybe I'll take this one. So we decided to use Terraform because we use it not only for the serverless itself, but for other systems, which we are using globally in the OLX. So as we would like to keep it in line with all of the systems, we decided with the Terraform. But if you would like to use the CloudFormation or other systems that give you such ability to keep it infrastructure as a code, yeah, let's use it.
Yeah, I would add to this answer that like there's no silver bullet, right? You can have one technology, you can have another. It's just a matter of sometimes it's just a matter of preference, because many tools can serve really well if you use it right. So at the very end, sometimes it doesn't really matter what you choose. So yeah, feel free to experiment.
All right, so maybe as a professional, we could say it depends.
Yep, exactly.
Yeah,
exactly.
Okay, so let's move on to the second. Yes?
I think one more thing in here. Everything depends on the needs.
Yep.
And your team capability. So if your team is more fluent in CloudFormation, use CloudFormation.
Definitely.
If you think that Terraform is more, it will be easier for you because you use Ansible, for instance, previously, use it.
All right, thank you, guys. So the second question is from Piotr. He's asking, what is the best way to test serverless applications? How to do it in the pipeline, so basically during continuous integration?
Maybe I'll try to answer at least portion of that question. Of course, it depends. Yeah, but testing serverless is the most difficult thing for me. It was at the very beginning for me because we don't have this locally. So when you have a really complex system, it becomes at some point a problem for the whole team, how to test it properly. So we tried different approaches. You can, for example, create an environment on the fly, like an environment which allows you to test it either via unit tests or end-to-end tests or some smoke tests, but you need to set it up somehow. So those things like Terraform and these CI/CD scripts can do a lot to make your life easier. For example, you can create a branch, and for special naming conventions, you can set up the whole, I would say, the whole environment just for the development purposes, and you can use it as long as you want. And
okay,
then
so kind of a short-living environment only for testing purposes.
Exactly. Yep, exactly. Right. But this is just the only one of the possibilities. So it's not like the only way to do that. We did that. It worked quite well. It had its problems as everything, but it's one of the approaches.
And this is the time when the DevOps and SREs are really handy because they always find the good solution. Yep. Which will feed the organization itself and product requirements.
Mm-hmm. Okay. All right. Thank you. So another question also from Piotr, actually. Can vendor lock-in be avoidable when we work with serverless solutions?
Okay, I'll try to get this. Mm-hmm. If you work with the pure serverless, like AWS Lambdas and other components, unfortunately, vendor lock is here. So you'll be keeping this vendor as long as you would like, as you will be using his services and you will not decide to rewrite them. We mentioned at the beginning the Kubernetes as an option, kind of a serverless, because Kubernetes provides such ability to make small elements, running elements, scale them quite fast. And in theory, Kubernetes can be run in all of for the cloud providers, even though you can run it on the bare metal if you would like in your own data center. So I think this is the only way currently for not locking you with the vendor for a longer time period. So this is why, in case you jump into the serverless, decision needs to be done not only on the hype generated by the engineers, but after the deep analysis of company needs and possibilities to keep the serverless with you, because you'll be locking yourself for a longer time period.
And you need to still to count money at the end. Designing any system which is not a simple microservice requires a lot of work, not only by engineers but also business analysts and people who at the end who pay for this whole platform. So it's a very complex problem.
All right, thank you. There is one comment actually from, we have a bunch of Piotr's today. All right, Piotr Połcik just left a comment. That's an unexpected cliffhanger. Actually, I'm not pretty sure what is it all about. Could you please, Piotr, elaborate a bit, or just leave our question so that I can read it. Thank you in advance. All right, next question is from Tomasz. He's asking, oh, that might be a bit tricky, I think. What do you think about self-hosted serverless solutions?
Yeah, I kind of expected this question, actually. I was waiting for it.
Really? Okay.
Yeah. Because I'm not a big fan of evangelizing the concrete solutions. I just prefer using the right approach for my particular problem. So when it's okay for me, when I accept all of the drawbacks of, for example, this serverless.com, right? There is a framework for that, and we can still use it. If it fits our needs, why just don't use it and have fun? And if your system, because at the very, very end, everything ends on when we are talking about a commercial product. At the very end, there is something which is called money, and you need to pay for something and you get something out of it. So if your cash flow is positive, I would say you can use anything you want. So in my experience, I also had many, in my career, I had many situations where the decision regarding technology, I would say, was totally irrelevant. At the end, the system made money. So it depends on your needs. If the framework is something which you are comfortable with, just go for it. And that's it. I don't want to tell you like, okay, you must do this because this is the only way to do that. No, it always depends on the problem.
It all depends. All right.
Yeah.
I loved it. I actually love this phrase. All right. As far as I see, we are out of questions, to be honest. All right. Last 30 seconds to ask any questions. If not, we can proceed to the very end. All right. There are no new questions, actually. Guys, thank you for being with us. Thank you for sharing knowledge with us and with our audience. And
thank you for having us.
Yeah, and see you soon. Bye.
Yeah, thank you. Bye.
Bye.